Good afternoon, everyone. Folks are still joining, so we'll just take a few more minutes for people to get signed on this afternoon. All right, I'm gonna go ahead and kick this off. We will get started. Thank you so much for taking some time out of this lovely sunny afternoon to join the Maine Climate Council for the second in our webinar series, Forests, Biodiversity, and Agriculture. Just so you can see on this screen, we do have one more webinar coming up after this one. If you're interested in learning about the latest science on sea level rise and marine systems, you will not want to miss this webinar on June 5th, 12 to 1 p.m. And also, as a reminder, these webinars are all recorded and the slides are posted online after the event. So if you missed the first webinar, or if you missed one of the second or third ones, you can go back and view the recording, look at the slides. Those are all posted on our calendar webpage for the Maine Climate Council. So I think Abigail or Casey will drop that link into the chat so you can go to our calendar webpage and follow up for the materials after this webinar. So really excited to have this wonderful group of experts here today to share the latest science on climate and its impacts on forests, biodiversity, and agriculture. Just a quick housekeeping before we get started. After the presenters share their findings, we will have a question and answer session. We will primarily use the Q&A feature of Zoom, which you can find at your toolbar at the bottom of your screen. So if you have questions that come up during the presentations, feel free to start putting those questions into the Q&A box, and we will field those once the presentations are over. And then again, we will send out these materials after the webinar, and they will be posted on our calendar webpage. So I am very excited to turn this over to the scientists, and I will drop my screen here, and we'll now turn it over to Ivan Fernandez, who's going to intro the presenters for today's webinar. Thanks so much.
Great. Thank you, Molly. You see my screen?
That's great.
Okay, great. Thank you. Thanks for everyone for joining us here this afternoon on what up here is a really lovely sunny afternoon. For the second webinar in the STS series, my name is Ivan Fernandez. I'm a soil scientist and a biogeochemist at the University of Maine, and I'm one of the co-chairs of the Scientific and Technical Subcommittee, along with Dr. Susie Arnold, who's at the Island Institute, and I suspect most on the webinar know of her. Some of you saw her last week doing the introduction for our first webinar in the webinar series. And the other co-chair is Dr. Stephen Dixon with the Maine Geologic Survey, who will be doing the introduction for next week, the third of our webinar series. The STS, Scientific and Technical Subcommittee, is roughly 45 scientists from Maine, or almost all from Maine, all studying and students of Maine. The image actually on the introduction slide here is pictures of Maine scientists in action throughout the state, showing some examples. A few of them, I think one of them you'll hear from today, that's on this image. And so besides writing science assessment reports and proposals and papers, scientists are throughout the state gathering the kind of information that we depend on to make science-informed decisions around Maine's climate response. So just to get us started, and I suspect everyone on this webinar is familiar with the Maine Climate Council, but for context as to who we are as the Scientific and Technical Subcommittee, The Maine Climate Council is a 39-member council appointed by the governor to develop Maine's climate action plan. And the council was established in 2019 to develop the climate action plan that was delivered the following year in 2020 that we all know of as Maine Won't Wait. The Scientific and Technical Subcommittee is one of two subcommittees within the infrastructure of the Maine Climate Council, the other being the Equity Subcommittee. And then there are 6 working groups, and the working groups are charged with developing strategy recommendations that are handed up to the council for the development of the climate action plan. And the climate action plan is due to be updated this year. It's updated every 4 years. And so this past year and right now, everyone is has been very busy with this process, with those draft strategy recommendations due to be delivered in June at the quarterly council meeting. The working groups are transportation, buildings, infrastructure and housing, energy, community resilience planning, public health and emergency management, coastal and marine, and natural and working lands. And the last one, natural and working lands, not solely, but is the working group where the topic of today's discussions are particularly relevant. What do we do? What is our charge as a scientific and technical subcommittee? The same law that established the Maine Climate Council in 2019 established us as a subcommittee to identify, monitor, study, and report out to the council and to the working groups findings and recommendations related to climate change in the state and its effects on the state's climate, species, marine and coastal environments and natural landscape, and on the oceans and other bodies of water. We do this in a variety of ways as a subcommittee, but none more critical than the development of a science assessment. And the Maine Climate Council has been, from the very beginning, grounded in science-informed policy development, and our charge is to bring forward the latest science across mitigation, adaptation, resilience. So we did that in 2020 in support of the original Maine Won't Wait. And on this slide, you can see the first report, which was a relatively comprehensive and extensive report within the confines of, or the boundaries of, our charge. 370 pages, scientific assessment of climate change and its effects in Maine. A year later, in 2021, we issued a relatively short and focused update, not as expansive as the process we're undertaking now. And this past year, we have been working, we being STS, on the development of an update that's built on the 2020 report. So it doesn't replace that, but builds on that, particularly focusing on the latest science that has come forward in the interim from the original assessment. And so the scientific assessment of climate change and its effects in Maine 2024 update should be issued literally in a couple of weeks. And these webinars have been an opportunity to bring some of the highlights of those findings forward in anticipation of that release and of the in support of the working group's activities. So today we have 3 areas that we're going to focus on the sort of the landward side of the science, having to do with agriculture, biodiversity, and forests, presented by several of our STS experts, and experts widely recognized here in the state of Maine. Before I hand it over, I just want to close these introductory comments by sharing that I think this is really a critical and transformational time that we live in during this rapidly changing climate. We have and will discuss elsewhere the many facets of the urgency of the broader science around the climate crisis. And yet, having been a scientist in this realm of science for nearly 50 years myself, I'm struck by the tremendous focus climate change has provided for society on the importance of our natural resources, the people who manage them, and the communities that depend on them, which is all of us. This brings with it tremendous opportunities for investments in these resources and people, and appreciation for the importance that Maine's farms, forests, wetlands, and biodiversity represent to our present and our future quality of life, and underscores the importance of the work that we do in the council and in all of the supporting bodies that support the council's work. So let's get on with the science. And the first presenting this afternoon will be Glen Koehler from the University of Maine Cooperative Extension, telling us some about the agriculture sector. So with that, I'm going to stop sharing, and it's all yours, Glen.
Okay, can you see my screen? Oh, can you see my screen okay?
Now we can.
Okay. And you can hear me, so I guess we're good to go. So my name's Glen Koehler. I work for Cooperative Extension at the University of Maine. My main duties are involved with tree fruit pest management, and I'm just going to cover some of the major points that came up in the upcoming 2024 STS update related to agriculture. Oops. So you did see the slide change, right? Okay. So the annual minimum temperatures have increased, and that's created a slight northward migration of the plant hardiness zones, which are the annual minimum temperature. Nothing too drastic so far, but it does make a difference. More importantly, I think, is what's coming up in the coming decades. That rate of change is projected to increase with rather striking changes in what will be the annual minimum temperatures, and that has effects on agriculture in terms of some of the perennial crops that can be chosen. And it also affects which pests and insect disease and weed pests can survive the winter. And it also makes opportunities for new pests to move into the state, which has already happened to some extent, though it's hard to distinguish what is just climate change versus global commerce and other impacts. Another change is the length of the growing season, which is basically the time between the last spring frost and the first fall frost. And those growing seasons have been getting longer. And what we see here is that by 2050, Presque Isle will have a longer growing season than Lewiston has now. So these are not small changes. From a regional perspective, it's a bit of a complicated graph, but you can see that by 2050, Central Maine, using Monmouth as a representative site for Central Maine, becomes similar to what southern New England and northern Pennsylvania has right now. And by 2085, Central Maine becomes like southern Pennsylvania and mid New Jersey. So these are quite different agricultural production areas, but this is in terms of temperature. Precipitation effects are more difficult to predict. But even with the changes in climate, the sunlight regime and the soil regimes are not changing. So it's really difficult to predict how this will affect agriculture. But it certainly will have effects. For the time being, or what we've already seen, is extreme and variable weather. And attributing that to climate change is a difficult science, but the climate scientists do seem to be getting a handle on it. And if you talk to growers, they don't have any doubts that the weather is getting more variable and extreme. An example just from last year was May 18th, we had an early bloom. It wasn't extremely early, but it was earlier than normal, but then we had a late spring frost. So even though the frost dates are generally getting earlier in the spring and later in the fall. That's an average. The average doesn't count. What counts is what happens to each individual year. And last year we had a spring frost on May 18th, and with that early bloom, the trees were more sensitive, and this is what resulted. Many growers had a much reduced crop, and the crop that was there was oftentimes compromised by freeze damage, such as shown here. Maine actually got by with less freeze damage than other states because they were even further along when that frost hit. That's a temperature effect. This next slide just shows variations in precipitation. 2020 was one of the driest growing seasons we've had in many years. And then last year, 2023, was one of the wettest. So it just shows the variation from year to year can go from boom to bust or bust to boom. This has impacts on the need for irrigation and also the need for drainage. We're not helpless against this. I mean, we can't change a grower cannot change the weather they're dealing with, but we do have information tools, and this is a bit of a complicated slide, but just shows something we used this year. We had basically unprecedented heat conditions during bloom again, this time for fire blight disease, which is a bacterial disease that moves very quickly and can devastate a crop. And we have information tools to help growers know when this is developing, and there are things they can do to mitigate or prevent the damage. Moving to the agricultural contributions to greenhouse gas emissions, this slide summarizes data from the Maine Department of Environmental Protection and Stacy Knapp, who I believe is on the webinar here. And it just shows from 1990 to 2021, the different components of agricultural greenhouse gas emissions. The red at the bottom is enteric methane. That's basically cow burps. Ruminant digestion produces methane, and their manure also produces methane. And there's been a slight decline in enteric methane over the years and a slight increase of manure methane, but basically fairly stable, as is the manure nitrous oxide. The one that's changed is the soil nitrous oxide. And just looking into that a little closer detail, the components of that are here, and most of those are stable. Livestock waste is the black at the bottom. Manure runoff it's actually gotten much better and been reduced. Crop residues and fertilizer runoff are fairly stable, but what's changed is the fertilizer component, again, of soil nitrous oxide emissions. And I do not know the source of that change from basically 2006 till 2021. It's not a change of acreage overall. It's probably not a change of fertilizer rates. So I assume it's either just a change in reporting method or a change of fertilizer type. When you look at agricultural emissions from Maine, the vast majority are related to livestock, and the ones on the left are all livestock only sources. And on the other ag sources, a big chunk of this light brown soil nitrous oxide from fertilizer is also related directly or indirectly to livestock, because a lot of our ground is used to grow silage corn, and that corn is grown on acres that help contribute to that soil nitrous oxide. So livestock is and this is a national trend too, not just Maine, is the largest component of agricultural greenhouse gas emissions. However, you need to put that in context. The agricultural production overall is only 2% of Maine's total greenhouse gas emissions. So this is a big chunk of a very small piece. And then finally, agriculture is food, and the production of food is actually less than the food-related greenhouse gas emissions. A larger portion comes from the distribution, retail, and consumption end. And then when you get through the end of this process, in the end, about 30% of food is lost as waste. So reducing food waste is a huge opportunity for reducing food-related and agricultural greenhouse gas emissions. And that is my last slide, and I will stop sharing.
Great, thanks so much, Glenn. I will now turn it over to Kristen.
As soon as I stop sharing, and I can see how to do that. We practice this. Hold on. There we go.
All right.
Have I stopped sharing?
Yep.
Okay, I think we're all set up here. All right, can you hear me okay?
Yes.
All right, great. Thank you, Glenn. I love that last slide, and I've actually got a sticky note on my fridge about the amount of food waste to remind my family not to waste their food from last time you gave that presentation. Hi everyone, my name is Kristen Puryear. I'm an ecologist with the Maine Natural Areas Program, and we're part of the Department of Agriculture, Conservation, and Forestry. And I'm going to share what our group compiled, some of the highlights for the biodiversity chapter for the STS updates. So starting with some broad trends, kind of start high and move in more specifically. For decades, habitat loss and invasive species have played the largest role in the loss of biodiversity. However, recent evidence shows that climate change is having a profound effect on the status of plants and animals worldwide, with increasing evidence of species movement or loss due directly to the factors associated with the changing climate. Some general trends at the worldwide scale and local level both indicate that the pace of change to natural systems over the past 50 years is unprecedented and accelerating. The impacts not only cause significant losses to biodiversity, but also to ecosystem function and health. Species that are particularly vulnerable are those with small or isolated populations, such as endemic species that have a very limited habitat range, or those that cannot move quickly in response to shifting habitat, either due to limited mobility or fragmentation of the landscape from development. And at the whole ecosystem scale, there are mounting predictions as to how changing climatic factors such as increasing temperature, storm severity, and precipitation will undermine the structure of habitats and even whole food webs by creating seasonal mismatches. So, for example, the insects emerge, and if it's not at the time when the young birds need to be fed by adults, that doesn't work out so well for those baby birds. Also, new spread of diseases and new diseases and parasites. Some examples of impacts to whole ecosystems and food webs that we can relate to here in Maine include the mass mortality of Atlantic shrimp and loss of kelp beds driven by warming ocean temperatures, with cascading impacts, of course, to fish, shellfish, and other marine life, as well as the fishing industry. And a significant bird population study across North America demonstrated how there can be climate-related trophic or food web breaks, which are partially to blame for the decline of 160 million insect-eating birds since 1970. And researchers and land managers alike have also witnessed the loss of forest understory plant diversity due to invasive species such as common and common and glossy buckthorn, which have expanded their range in part due to warming temperatures. This in turn has the domino effect contributing to loss of native species through overcrowding the forest understory, decreased carbon sequestration, and increases in invasive earthworms. At the species level, 8 new wildlife species were recently added to Maine's list of endangered and threatened wildlife, many of which are additions driven in full or part by climate change, such as salt marsh sparrow, which is threatened by sea level rise, and the tricolored bat, which has suffered dramatic population declines due to white nose syndrome in combination with climate change pressures. Several bird species that rely on montane spruce fir forests for breeding are already of conservation concern throughout the region, in part because these forests have very limited distribution and only occupy about 1% of the northeastern landscape. So as these subalpine habitats are projected to move upslope, species such as Bicknell's thrush, which is now listed as threatened, are at risk due to habitat shrinkage. Similarly, 21% of Maine's resident and visiting butterfly species are listed as state endangered, threatened, special concern, or actually extirpated, and a quarter of those are considered imminently threatened by climate change, including changes in the quality and quantity of their specific habitats. These include butterflies that occur in alpine tundra, like the Katahdin Arctic, also boreal forest and northern bogs. And finally, an Audubon study projects that with 3 degrees Celsius warming, more than 100 North American bird species could experience population and range shifts during both the breeding and non-breeding season, including losses to Maine's common loon. Results from Maine's breeding bird atlas have already shown new birds moving into Maine since 1983. That was the last atlas. Meanwhile, several warblers and grassland birds have lost parts of their range, and others like the eastern bluebird have expanded their range and increased in Maine to the delight of many. Or for the case of the boreal chickadee, as you can see on the graph on the right, they have started to move north, resulting in population shrinkage. Over the last 125 years, there have been more extinctions due to habitat loss than due to climate change. And habitat loss is still the primary driver of species loss. However, as noted a few minutes ago, it's expected that this trend will shift and climate will contribute both more directly and more immediately to extinctions, as well as range shifts, so local extirpations in the future. For example, in the Northeast, models suggest that population sizes and range of many common and culturally important species, such as ruffed grouse, black-capped chickadee, black spruce, balsam fir, that these will decrease. Even moose are being affected as they are susceptible to heat stress, changing vegetation, and increased parasites such as winter ticks. Furthermore, warming stream temperatures and decreased summer flows are projected to cause significant declines of cold water fish, such as eastern brook trout, as these streams become uninhabitable or compromised by non-native fish species. And tidal marshes, which are these incredibly biologically productive ecosystems that support both terrestrial and marine diversity, are being threatened by rising sea levels. These wetlands will be forced to move inland, as depicted in that graph on the right, or graphic on the right, but only where there's suitable topography and natural land cover. And recent models suggest that there's not nearly enough space available to replace all of our current tidal marshes when they flood. So the important summarizing point here is that as climate-related pressures increase on species and habitats, this compounds existing threats from habitat loss and fragmentation. So species likely to be vulnerable are those that are already rare or on the state or global level, or have narrow or specialized habitat needs. And lost or fragmented habitat from development can reduce the likelihood for their potential dispersal to areas that are more climatically suitable as that happens. In Maine, it's worth noting that the pace of development remains high in central and southern coastal regions, which also happen to be regions with significant concentrations of imperiled or at-risk plant and animal species. So rarity and development bumping right up against each other. The last few slides, they had some sobering information there, so I want to put a bright light on for everybody. Scientists, landowners, and land managers do have tools and a set of principles which, if used, can help guide conservation and restoration actions that can mitigate or reduce the impacts of climate change on species and habitats. One such principle is that geological and physical diversity across landscapes provide the underpinnings for species diversity. And by protecting a diversity of geophysical settings, also known as the stage, we can make that physical diversity available for species even as climate changes and species move. That type of conservation should be complemented by strategically locating connecting landscapes, such as large undeveloped habitat blocks, extensive riparian networks, or large wetland complexes, to allow potential for species adaptation and resiliency, and of course to support our wide-ranging critters like moose, bear, and bobcat. In addition, research over the past 3 decades by state biologists from Maine Natural Areas Program, Department of Inland Fisheries and Wildlife, and Department of Marine Resources has contributed to the knowledge that there are discrete areas of the Maine landscape where a disproportionate concentration of at-risk species and habitats are located. These focus areas of statewide ecological significance should be considered part of the scaffolding along with nature's so-called stage and connecting undeveloped land, which can help increase the viability of species and support adaptation and resiliency as climate changes. And then as we talk about the array of impacts that climate change has on people and communities, it's valuable to emphasize that the concept that protecting biodiversity within native natural habitats has the co-benefit of providing nature-based solutions. For example, land management, restoration, and protection measures that reconnect streams and tidal rivers, anticipate sea level rise and marsh migration, or preserve large blocks of connected habitat will also pay out in carbon storage, greenhouse gas mitigation, floodwater abatement, water quality, and more. Consider old forests, which support the largest carbon pools of all northeastern forest types. So these are the ones over 150 years old, while concurrently supporting the highest biodiversity, thanks to their physical diversity, all the microclimates and microhabitats. They're also credited with providing important nutrient cycling, clean water, oxygen, and of course, recreational opportunities. Another good example is well-buffered riparian areas, which provide invaluable functions of water filtration, stream bank stabilization, floodwater retention, climate refugia, and travel corridors. And these riparian areas may allow Maine to remain a regional stronghold for our beloved brook trout. And while Maine is about 25% wetland of many diverse types, our approximately 750,000 acres of exceptional and diverse bogs and fens, these big organic wetlands, store the most carbon of all our wetland types and are home to many specialized and at-risk species of plants, insects, and birds. So in summary, climate change is causing unprecedented impacts to biodiversity, including here in Maine. Historically, habitat loss and invasive species were the primary drivers of species decline, but new research has identified the first species losses and population shifts directly as a result of climate change. And this is compounded with increasingly fragmented habitats and existing stressors. So we are likely to see more local extirpations. However, conservation planning, restoration, and management tools are increasingly being deployed to preserve climate resilient landscapes, maintain corridors for species movement, and at the same time, protect critical ecosystem functions that benefit both people and biodiversity. And that's what I've got for everybody today.
Great, thanks so much, Kristen, for the great presentation. Next up is Adam on forests.
Great, thank you, and hopefully everyone can see my slides as well. I'm Adam Daigneault. I'm Associate Professor of Forest Policy Economics here at the University of Maine, and I'm speaking on behalf of all the authors who helped put together the chapter on forests and forestry. Just some things to get at the highlights of what I'm going to talk about in the next few minutes. So one key thing to remember, it's not just about climate impacts, but the role that our ecosystems can play in terms of helping to mitigate climate change. And so a big headline is that Maine's forests and wood products currently offset nearly all of Maine's fossil fuel greenhouse gas emissions. Climate change is expected to have a mixed effect on forest growth, yield, and ecosystem health. So similar story to some of the aspects that Glenn talked about in agriculture, driven by a lot of the same phenomena. Maine is becoming more vulnerable to wildfires, pests, and disease as climate changes. But there's, like Kristen talked about, there's both active and passive adaptation measures that we can employ to enhance, maintain, and restore the forest values, and for the myriad of objectives that we as landowners and citizens of Maine have in terms of what we should be doing with our forests. Just a reminder of the overview. So forests comprise 89% of the state's land area, which is more than 17 million acres, and more than 90% of that is privately owned. So any sort of interventions that we do really have to take into account those private landowners. We have what's considered to be a transitional ecosystem, which means in the south, it's largely made up of temperate hardwoods, and in the north is boreal softwoods. And generally, as climate change sort of occurs, you're going to see basically a northward shift such that a higher proportion of the state becomes more hardwood dominant as opposed to softwood. And the sector itself contributes $8+ billion per year to the state's economy. And so this is obviously through more active forest management, which can actually play a key role, not just in serving our sort of rural communities, but also to provide ways to improve forest health and mitigate climate change. So that big headline I led with is that Maine's forests currently sequester nearly 15 million metric tons of carbon dioxide equivalent per year, and the harvested wood products that we take from harvesting contribute another million metric tons. So together, forests and products offset nearly all of Maine's fossil fuel greenhouse gas emissions. We've seen persistently high rates over the last 10 years, but emerging threats of pest, disease, fire, and also our aging and more densifying forests could sort of reverse this trend. And that's what we're sort of seeing here, at least in the last two bars of this plot, the idea that although, again, we continue to sequester more than we emit in terms of Maine's forests, we could be close to reaching that sort of plateau in terms of the sort of maximum potential that forests could play in terms of sequestration on a year-on-year, year-by-year basis, at least under the sort of current status quo. On the forest productivity side of things, what we're seeing is that some areas may see higher growth due to longer growing seasons, so very similar to what Glenn explained in the agriculture side of things. But other areas may decline due to greater incidence of droughts and pest occurrence. So it's hard to say just blanket across all 17+ million acres of forest, X will happen. Right? It's very much sort of space and time dependent. But the other thing, again, is I'll keep harping on this, is that forest management is really a strong influence of future trends. Typically, that can go in a more positive manner, again, if we're out ahead and in front of what these sort of the downsides of climate change may be, or taking some advantage of some of the positive effects associated with longer growing seasons, carbon dioxide fertilization, and other things that climate change might be producing. I talked about the idea of this persistent and emerging threats. So Maine's really, our forests are really at a biological tipping point with ongoing threats from climate change and natural disturbances at large, including wind and fire. And I think we've experienced a lot of sort of wind and precipitation events, particularly even over the last year, where we've experienced a lot of wind throw or tree loss. As a result, and many on the call probably have examples of where they've experienced that on their own land, if not their neighborhood or towns. As well as invasive species, we're continuing to see threats coming in, particularly from the south and west in terms of various species that could be affecting us. And another thing to keep in mind is this idea that as sort of our management of our forests goes down and our harvest levels goes down, that actually is leading to more a higher amount of relative density in terms of what our forests are. And so while some aspects of sort of maturing forests and more dense forests do have some positive effects on biodiversity and other aspects that Kristen talked about, we just have to be careful about sort of where these places may be and the types of forests that are sort of growing, because as those forests become more dense, they also become less healthy, particularly if you're thinking about this from a sort of forest ecosystem, bigger and contribution to timber supply and other aspects like that, such that the forests start to do things like self-thinning or start to die off again as there's that more competition for light and other resources. On the wildfire threat side of things, really, Maine has relatively low wildfire risk, but serious wildfires have occurred in Maine, especially during droughts, and we can think back of the 1947 fire that even comes up in discussions today. In more near time and place, you can think about the 2023 Nova Scotia wildfires that burned more than 60,000 acres. And the key there is that Nova Scotia has a similar forest ecosystem that we do, which basically means that we could be facing similar threats. And so risks include dense forest fuels. We have a number of houses in the forest interface, and also lack of wildfire fighting capacity. So although the Maine Forest Service and its affiliated wildfire collaborators do well on fighting fire to the best that they can, there's still a lack of capacity that could really affect us if the risk continues to increase. And so really the idea here is that we do have projections that, although again, it's still relatively low compared to places out west in particular, or in the southern US, there is increased wildfire probability in Maine due to climate change, where that percent change in fire probability is some of the largest in the country. So just thinking about sort of relative change could be quite high. As we all know, there are opportunities to doing adaptation, but again, barriers that folks are facing. So as noted, active and passive adaptation can enhance, maintain, and restore the mitigation values of forests. And because Maine's forests are largely mixed and provide a wide range of ecosystem services, it really sort of is dependent on what the objective of the landowner or the user is to determine really what the best mitigation or adaptation scheme should be. Those who researchers have talked to, particularly on the sort of forestry side of things, have noted that they were concerned most with warming winters and declining tree vigor, while urban foresters really cite extreme weather and safety hazards from storm damaged trees as highest concerns. And again, that's something we've experienced in the last 6+ months that many of us can have sort of direct experience that we can relate to. Many forest managers believe that adaptation really should become more of a priority, but they acknowledge that there's many barriers that they face, despite maybe having a good idea of what type of adaptation measures they might want to be able to take. There's still barriers to actually undertaking that. So one is this, that there's increased public use on conserved lands, right? So that might change sort of what and how you can do on those lands. There's generally still public opposition to harvesting. So I talked about this idea that our forests are becoming older and more dense, right? And that's not necessarily beneficial for the entire sort of state, right? And so in order to sort of mitigate some of the negative impacts that can come with that, you have to do some aspect of harvesting. If you want to do harvest or some sort of adaptation measure, there's still high cost of treatments and really limited timber markets, right, that are constraining the ability to have this be more of a demand side thing. We have to think about ways of how do we actually get folks in the woods to do all this great work that they know how to do. Information is sort of variable in terms of what spatial scale that people can conduct things on. And I think one of the first questions we had, even in the chat or the Q&A, was like, well, what trees can we plant and where, right, to help adapt to climate change, right? And that's going to really depend on where you are in the state and sort of how wide of a scale you're really looking or be able to manage over. And finally, determining sort of appropriate on-the-ground management. What can you do to turn the science into action? And then finally, just a few other highlights that might be of interest to people. So I touched upon this briefly, but the idea is that tree lines, the growing season, and foliage timing are all shifting what I call up and out. So trees are going higher up in elevation. The growing season is becoming wider, and foliage timing is happening such that it's later on in the autumn months. So just for context, peak fall foliage is nearly 2 weeks later today than it was in 1950. And it's going to be about a month later compared to 1950 by the sort of mid-century. Another thing, as we talked about, so Maine's forests already sequester a lot of carbon. Work that we've done both within the University of Maine and then in comparison to some other studies that found that shifts in forest management could increase carbon sequestration by another 20% or more without necessarily changing sort of what sort of historical harvest levels may be, right? And that's a lot has to do with sort of the management that we can do and sort of optimizing how we can do that. All right, and finally, we talk a lot about sort of the biophysical impact factors of climate change, but we also need to note that Maine's forests have been managed and harvested for for centuries, and so we need to acknowledge that there's a lot of socioeconomic factors that are likely to be driver of sort of Maine's forest futures beyond just sort of the biophysical impact of climate change. So with that, I thank you for their time, and I welcome the questions that are going to emerge in the discussion.
Great. Thank you so much, Adam, and everybody for your really informative presentations today. We've got some great questions coming into the chat, so we'll try to get to as many of them as possible before the hour is up. I'm going to start with a question that does tag on to what you were just saying, Adam. So this person asks, are there resources that you would recommend that speak to succession planning for trees, particularly for urban forests? What trees are likely to be lost or suffer greater impact, and what sort may be suitable for replacing them to maintain tree cover and tree benefits, and again, particularly in urban forests. And I see that Ivan has put some website resources in there. If you would not mind dropping those in the chat, Ivan, instead of the Q&A box, that way everybody can see them. But Adam, if you want to take a shot at that, or I'm not sure if there are other folks that have thoughts on urban tree succession planning.
Yeah, so I'm going to caveat that I'm not a tree physiologist or anything like that. I'm a economist and a policy person, but there are a lot of resources out there, almost to the point that, yeah, it can be hard to choose on which ones. Ivan talked about aspects of what the USDA Climate Hub provides. There's also, I know there's the U.S. Forest Service puts together a tree atlas, and so you can look up specific trees, and it'll sort of tell you sort of some of the physiology aspects. I would say if you really just want to do a rule of thumb, look for what's growing right now in New York, New Jersey, and Connecticut, and it's abundant there, and think about some aspects of those trees to consider, because those are likely to be a little bit more hardy here as the climate shifts. I know there's a number of other studies that are being done in Maine right now to identify sort of additional species. One that comes to mind is black walnut. I know has at least been suggested, but there's 100+ species that can grow here, so it's hard to say. It's very sort of site specific. Yeah.
Great. Thanks, Adam, and thanks for those resources in the chat, Ivan. Hopefully those are helpful. I think this next question might be one for Kristen. Should we change our notions of invasive species from fighting them to welcoming some or all as they migrate north? What does the science have to say about that question?
It's a great question. It's definitely worth discussing. So yeah, I guess the first thing I would say is to define, just put a definition on the word invasive. So we think of invasive as being some people think cattails are invasive, which they are. They grow in a monoculture, but they're native species. Well, 2 of them are native species. They just happen to grow in extensive and act in an invasive way. For species that are not native but invasive into otherwise natural habitats, think of something like, well, I mentioned the buckthorn, but you can also think of bittersweet, which people see, pulling down the trees in the backyard and climbing up their big white pines. Those are species that have been introduced and have been around for quite some time, but are actually causing physical and biological and even chemical changes within our natural ecosystems. And those are ones that I would still put in that list of bad actors, for lack of a better word. As far as the species that are moving in because climatic conditions are changing, whether that's temperature or precipitation, that is something that we just, I think, have to basically keep an eye on, and it may be a species by species situation, kind of like Adam was just mentioning, place and species based. But one thing I think that we can all anticipate is that the traditional arrangement of species in, say, a northern hardwood forest that we see now may not always be that same arrangement. So we're going to see some novel combinations of plants and then therefore animals as conditions change. And that's not necessarily a bad thing. That is the way that these biodiversity is going to adapt. It will have to. We can't just leave a blank spot where a plant used to be because we don't want the other one coming in. So to some degree, allowing these novel species to just move in on their own, if they're not causing big upsets to the whole ecosystem, may be something that we do have to let go. But I don't think we can let go of the concept that there are still some bad actor species out there that we are going to continue to work to remove or mitigate, because they are actually causing a lot more, undermining these natural communities to a great extent, and making them less resilient to any other climate changes that will be coming.
Great, thanks, Kristen.
Yep.
A question for Adam, and I see that you might be typing an answer. How would growth in Maine's forest product sector impact forest carbon trends? And I lost the question, it just disappeared, but I think you saw it.
Yep, so I can answer quickly. So the question, as I made a comment about how we still need some active forest management, and that often ties to, when we talk about active forest management, that often involves harvesting trees. So the question is, sort of broadly, that we face is, if harvests go up, is that good or bad for carbon sequestration? And so, like anything that comes from a scientist, it's sort of complex and depends. But if you really want to think about it, in the short run, as long as that forest is not completely mature, there will be some trade-off between harvesting those trees, converting them into wood products, and then what you see in terms of sequestration rates, because you're removing stuff from the stand, and not 100% of that is going to get converted into long-lasting products, right? The counter to that is that then you're opening up more light, water, and other resources to allow the trees that are remaining to grow faster. And so often there's cases, again, where you actually may get higher sequestration rates over the long run as a result, right? And so it's a sort of a short-term, long-run type of question. But generally, you need to have some active harvesting to really keep sequestration happening. Otherwise, you're going to reach this saturation point where you sort of the relative density is so high that trees are just competing with each other.
Okay, and then this next question I think is related. You mentioned suggested changes in forest management to get that 20% increase in sequestration. How do those suggested changes interact with biodiversity conservation? Are they pulling in the same direction, different directions? What are you seeing there?
Yeah, so a lot of the emphasis that we've sort of converged to, not even like with the intent of some of our studies, has really been that a real sort of important sort of approach that we could take is what we call a triad approach. So the triad approach is the idea is that you have a certain amount of the landscape is intensely managed to help meet like sort of our timber supply. Another proportion is actually very extensively managed, similar to what a lot of forests in Maine are today. And then another type is essentially set aside. So this is picking all the areas that Kristen said are really biodiversity rich or have the potential to become more biodiversity rich, trying to find these areas, keep them connected, other aspects like that. And so by removing some of the stress on some of those areas and putting more resources in a smaller area to grow those trees faster, larger, and more healthy or whatever, you can sort of allow us to reach that sort of happy medium where you're actually achieving both. So really the idea is, again, obviously it takes more coordination, but we found that at least scientifically and sort of mathematically, it can add up that you can benefit both, right? But it is going to change. It is going to require sort of a change from maybe what exactly we do traditionally on the ground, at least at a landscape.
Thanks, Adam. This is a question for Glenn. We tend to think of climate change in terms of what we will lose, but do we expect that the agricultural changes projected will eventually be a net economic gain for the state in the agricultural sector?
Well, the short answer is I don't know, but my gut says in general, overall, warming and a longer growing season should be an advantage for Maine agriculture, because that has been one of the constraints, is a short, cool growing season. But as an example of how tricky it can be, if you can remember that graph about how, Maine becomes like southern Pennsylvania and New Jersey over time, well, that's a great peach growing area, and we'd love to have peaches as a crop in Maine. It's a very high value crop. But it turns out what's happening in New Jersey is they're pulling peaches out because the variable weather is actually causing them spring frost damage that they can't grow peaches as well as they used to. So it's a complex mix of things. But to to settle on an answer, I would say yes, overall, it should be advantageous for Maine agriculture to have longer, warmer growing seasons. But one final influencing factor is Maine imports 90% of our food. And so it also depends on what happens in other states. So we're part of an interconnected food network, and what happens in other states also affects us.
Thanks, Glenn. We had a couple questions about carbon sequestration relative to carbon credit programs. So I'm going to start with this one. I think probably for Ivan or Adam. Can you give us some sense of how much carbon sequestration can be counted on from state-owned forests? And I think this is with the recognition that many of the forests in the state are privately owned, and private landowners, if they participate in carbon credit programs, can then sell those credits. So if we are relying mostly on state-owned forests for carbon credits, what is the potential there versus private forests?
Yep. So I'll go, Ivan, and if you can fill me in if otherwise. So roughly, I think about 5% or less of the forests in Maine are state-owned, and I'm going to look to Chris and others to correct me if I'm way off there. So I'll look to. But so, if you just look at state-owned, it's nowhere near those numbers that we're pointing at there. My understanding is probably state-owned forests are maybe a little bit older and mature, so the sequestration rates might be a little bit lower, but that doesn't mean that there's that means the storage and what they have in there is higher. So so there is some potential there. We should acknowledge that, but it's still very much in a minority compared to the private landowners. The other question, which has come up for a few years now, is exactly that if someone like in California or the state of Washington or something is purchasing carbon credits from a private landowner who's enrolled in the voluntary carbon market or something like that here, right? Who should be able to count for that? And roughly now, I think based on the latest calculations, it's something where along the lines of maybe 4 to 5% of the forest land is enrolled in some sort of carbon credit program. So again, maybe somewhat similar to the size of what our state forest lands are. So, in actuality, probably the state should not be accounting for that, right? But there's still, 90% of the forests who aren't enrolled in any sort of program, right? But as that market grows, we're going to have to do a better job at trying to account for where are these credits going, who's actually generating those credits, and really to ensure that we're not double counting something that maybe, again, a California or state of Washington or something like that is also getting credit for. So it's a great question.
I would just chime in. It also is important to track, and not only how many carbon credits are sold, but who they're sold to. And so the typical example that is probably most common that Adam just referred to is out of state. If they're still sold within state, that has a different impact on how we should think about the accounting from the standpoint of a state level carbon budget. And so it can get complicated quickly.
Absolutely.
And sorry, I was just going to add that there was a study done on ecological reserves, which are a series of lands that are public land set aside for long-term monitoring in Maine, and comparing that with forest inventory and analysis data. This is a couple of years ago, and it did show significantly higher amounts of carbon stock in the ecological reserve lands as compared to the average FIA plot, which is scattered around through the state. So I don't have more numbers on the acreage there. It's like 30% more carbon in the ecological reserve lands.
Yeah, Kristen's right. I guess the one thing I do want to bring up that people sometimes get confused is this idea of storage versus sequestration or flux. So we just have to be careful with, it's awesome to have forests that are old and mature, which means we have a lot of trees out there, a lot of biomass, right? But lots of trees and lots of biomass and carbon stock does not necessarily always mean that those trees are going to grow fast and more year on year. And it's that change in the actual biomass out there that we're using to measure the sequestration rate, right? So just another thing to just be careful about. Again, it's different objectives that we want. We want both fast-growing trees in certain parts of the state, but we really want those old, mature, high carbon stock, high carbon storage areas as well.
Great. Thank you so much to our panelists and to all of the folks who have put in great questions. I'm sorry we did not get to all of your questions, but hopefully that upcoming STS assessment will have many more answers to the questions that you have. So thanks for sticking with us today. Again, these materials will be posted on our webpage after the webinar, and we really appreciate you taking the time this afternoon. So thank you so much, and I hope everybody has a great rest of your day.
Thank you.